Please tell your colleagues to join me because when I start, let me give them like 5 minutes. As soon as I start, anybody I come after them is not will be recorded as sent for today's class. Is the course rep available? Course rep, Gideon, unmute and talk if you're here. Is Daniel around? Is Daniel is not around. Course rep is not around. I want them to unmute as soon as they come. Gideon. I'm doing. Is Gideon there?
Yes, ma. Good morning, ma.
Is Daniel around? No, Gideon is not around. Daniel is not around.
I'm here, ma. Good morning, ma.
The next 2 minutes.
Good morning, ma.
Okay, we can start the class now. So, like, I can see that Gideon is not available. Daniel is not available in the class.
We are available, ma. Gideon has been answering you, ma.
Okay, Daniel is
morning, ma.
available. Daniel, I'm making you co-host. Please help me take attendance now. Take attendance now, please. Give me a screenshot of the attendance now. Then, before we start taking class work, then you take another attendance. I will tell you. I will inform you when you're going to take the second attendance. Thank you very much. So, good morning, class. So, welcome to another class on flavonoids in 435. I think at the end of today, we're supposed to be done with flavonoids. We'll do carotenoid. After carotenoid, Professor Shiku should be able to come and take her part. I think her part is alkaloid and I think it's alkaloid. So, okay, alkaloid, saponin, and steroids. So you'll be done with the course. But I think I'm going to still make out time when you guys are settled to do revision with you in a class. So we can do all that we've done physical. So I can attend to your questions and such likes. So in today's class, I think we'll talk about quantitative analysis of flavonoid. Today we are going to talk about the reactions. Okay? We're going to talk about acid hydrolysis and alkaline hydrolysis of flavonoids. Now, in the exam, you might be asked with a detailed equation, show the alkaline hydrolysis of a named flavonoid. So you're going to give us the flavonoid you're going to use. In fact, not a named anthocyanin. So you're going to tell us the anthocyanin you're using the name before telling us the reaction. And reaction details is very important. Now, if you look at the equation, you realize that anthocyanin is that flavonoid that have sugar moiety, while anthocyanidin is that flavonoid that does not have sugar moiety. So when anthocyanin hydrolyzes, it's going to form anthocyanidin by alkaline hydrolysis. By alkaline hydrolysis. What happens in alkaline hydrolysis? In alkaline hydrolysis, we simply have a situation whereby the sugar moiety is being cleaved out, okay, from the anthocyanin to form anthocyanidin. So what we are actually doing in acid hydrolysis, what we are actually doing in acid hydrolysis is removal of the sugar moiety. Okay, now we can see that what we need to do this is just hydrochloric acid. And what happens is fission. Fission is breaking out. Okay, hydrolytic fission. So all these details should be put whenever you're writing the reactions of anthocyanin, named anthocyanin. Okay, acid and alkaline hydrolysis. So now, like I said, in acid hydrolysis, what we are looking at is the sugar moiety is going to be cleaved out because of the presence of acid. So we're going to move from sugar anthocyanin to no sugar anthocyanidin. Now, the acid hydrolysis is very simple. We're going to have a little challenges when you talk about alkaline hydrolysis. Now, you can also use the same name anthocyanin to show your acid and alkaline hydrolysis is permitted, right? And if you look at the example we have here, we have cyanine, right? Cyanine and cyanine chloride are the same thing. Now, under alkaline hydrolysis, what happened? Now, you can see that there is a cleavage of the bond of the main aromatic ring is cleaved out. But in acid hydrolysis, we are just taking out the sugar moiety. Okay, so that's the two differences you're going to look at now. Now, look at this. Now, my acid hydrolysis, I make use of HCl. Then in alkaline hydrolysis, I can make use of either sodium hydroxide or potassium hydroxide. They are strong bases. In that case, there's a cleavage of these two bonds. Okay. So how is it cleaved? That ring C is a point that the cleavage is going to occur. And when it occurs, we are going to have cyanidine, siluroglucinol, and glycol acid. Glycol acid. This glycol acid, if you look at that, is from the ring B. My ring B is where I got my glycol acid from. Now, the point of cleavage is where the acid is formed. Remember, when you're talking about hydrolysis or of alkaline hydrolysis of double bond, you're going to form an acid. So that's where the acid is coming from. Okay, so that's why we are having cyanidine, siluroglucinol, and glycol acid. So whenever we are having alkaline hydrolysis, we are going to have a two products because there must be a cleavage of bond. So the product depends on what the anthocyanin you're using. Now look at this, definin chloride. You can see the same thing happen. When there is a cleavage, I was still going to form my definidine, okay, siloglycinol, and the acid. Now that place you have an arrow is supposed to be OH because we have 3 hydroxy group there. So that's why we're going to have OH there. So whenever you're reading, correct it. Okay, difference between the two is the point of the number of hydroxylation in the compound, but the same thing happened. The same place we have an acid, the same place we're going to have an acid. So any other thing is alcohol because we have 3 hydroxy group in delphinin, while we have 2 in cyanide. So that is also going. So whenever you're looking at this, what you're supposed to look at, what is happening and what am I forming? So I cannot come and use 2 hydroxylation pattern in delphinin because that's what I saw in my cyanine. So that is all you need to know about the reactions, which is acid and alkaline hydrolysis of anthocyanin. Like I said, anthocyanin is the one that have sugar moiety. So when there's any hydrolysis, number one thing is that sugar moiety must go. But in alkaline, we have sugar moiety going as well as the bond cleaving to form 2 products. Okay, we continue. Any question here? Any question here? Okay. How do we synthesize anthocyanidine? Now remember, anthocyanidine is that aspect that does not have sugar moiety. Okay, while anthocyanin is the one that have sugar moiety. Now, this is a reaction method. We are going to use hydroxybenzaldehyde and acetophenone. Whenever you're told to synthesize a compound, the most important thing you're going to do there is the starting materials. Now, in an exam, if you know the product, you don't know the starting materials, it's as good as 0. So whenever you want to study reaction, make sure you understand the starting materials. Now, when you understand the starting materials, it's going to give you a guideline of what happened the next. Because when you cram something without understanding, you have tendency of missing it. Okay, if you look at this synthesis, you realize the steps show what happens. The first thing is going to be for the 2 compounds is going to form 1 compound, which is chalcone. What are they forming it by? In the presence of an acid, what happens? We are going to lose water. We are going to lose water to form chalcone. Okay? Now, from that chalcone, what happened again? We are also under the same acid. Whenever you have H plus, it's the same thing I'm talking about HCl. So whatever we are doing there is either we are hydrolyzing or we are adding a hydrolysis or dehydration. Okay. Now, in that case, in this second one, we're removing water. Okay. The second one, in the place of an acid, what happened? Water is going. Then this one, we are doing dehydrogenation. Whenever we are doing dehydrogenation, we want to form double bond. And that is why we are going to form our anthocyanin. So the reaction is virtually either we are adding or removing. addition or removal. So virtually we are doing the same thing. Having HCl, either adding an acid or we are removing, okay, to form our anthocyanidine. Remember, this is a kind of flavonoid. Remember, anthocyanidine are flavonoids. It's a kind of flavonoid. So the flavonoid that have sugar moiety and those that does not have sugar moiety. Now, that's why you see some fruits, they are sweet because of the presence of the sugar moiety. And some fruits are there that are not, that they are very good, they are potent antioxidants, but they are not sweet. So not all flavonoids are sweet. That means not all fruits are meant that say, this one is sweet because of the sweet, it cannot give you no. But that the essence is that whenever you have problem of sugar, disease from those ones that have sugar. If you look at the previous slide, you can see some of them have glucose. So that's why they advise people, if you have diabetes, people that have diabetes, don't reduce your intake of watermelon. If you must take small. And don't take the pulp aspect of it. You have to take both the bark, both the rind, and the seed. So that the bark and the rind will help to neutralize the glucose in the pulp. So some of us that want to take a watermelon, we are interested in just the sweet parts. You just go and just take only the juicy part. That's that part. That's a pink colored part. You just take it and just, because some people will just cut those one out. At times, even remnant of that pink will remain in the ring. And you say you've not taken anything. Because what you've taken is mainly sugar. And when you continue, you can end up having problem of sugar. I think I want to use this method to talk about that. Because these days I've encountered so many youths that are having sugar problem. So I want you to also be cautious, because the shelf in the market is full of sugar, in the name of your juice, in the name of your drinks. Even the so-called Zobo now has been adulterated. So these are the things that makes you see a youth that have not gone anywhere in life having diabetes. And when you start managing diabetes as a youth, it's a problem, because before you know, you start having kidney problem. So that's why you have to be careful of your cravings for sugar, of your cravings for sweet things. All the juices you see on shelf, they're all sugar and color. Please, for our health and safety. There's a matter that just happened now. A youth, that guy should not be up to 35 years, but he has diabetes. So things are really happening. So let's be very careful, please. Okay, talking about that. Now we are here in this lecture talking about benzo-5-pyrone. This benzo-5-pyrone can be a chromone or can be a flavone. So when I have my R determines whether I'm dealing with a chromone or a flavone. The essence of that is that it's going to help us in terms of reaction. There are questions that can come. We can talk about the reactions of flavone or reactions of. Now, this benzo-5-pyrone can occur as a 2-methyl or 2-phenyl. So when I have 2-methyl, I'm going to have it as chromone. When I have 2-phenyl, I'm going to have it as flavone. Okay. Now, in nature, a few derivatives of chromone exist in nature. The derivative of chromones occur in nature. The phenyl flavone, originally known as anthocyanins, occur in nature as glycoside. While chromone, there are very few that occur in nature. Then aglycone, remember when you talk about aglycone, it's one that does not have sugar. Okay, there are anthocyanidine. Anthocyanidine are the aglycones, the one that does not have sugar, while the one that have sugar, we call them anthocyanins. So if you look at this anthocyanin, when you talk about no sugar, talk about D. And when you talk about sugar, you talk about Ni. Okay. These anthocyanidins are the yellow pigments. A large proportion of its derivative occur in nature. The yellow pigments. There are some fruits that you see that are yellow in nature. You know, sometimes you see something like orange. Orange, like some of these orange you see in the shop, right? Some of them you see that their body is yellow. So all those fruits that have yellow pigments, they are presence of a anthocyanin, which is a glycone called anthocyanin. Now, why do we need all this benzopyrene? And the essence is for their reaction. Their reaction. Now, look at when we have 2-phenyl, we are having flavone. We talk about that these flavone occur more in nature, while chromone are very few in nature. So when they undergo reaction using conc base and heated, now it's going to cause ring of this pyrone to open, and we're going to have two products. So a question can be that the reaction, what are the products formed when flavone react with potassium hydroxide under heat? Or it can also come by drawing flavone, putting the reactions conditions and asking for the products. So this is a very easy question they can easily deal with. But some students end up failing them in the exam. Okay, these are general reactions of flavones. Now, when flavone reacts with potassium hydroxide, there will be a ring opening. The first thing that is going to be formed is orthohydroxyl dibenzoyl methane, which will continue again because this is unstable. So it's going to react again to form salicylic acid, acetophenone, orthohydroxyl acetophenone, and benzoic acid. So the question is that what are the products formed when flavone undergo reaction with conc potassium hydroxide under heat? What you're expected to do if you're told to write an equation, because at times your problem is you don't understand question. Somebody can ask you the product, you start writing the equation. It means you don't understand the question. And somebody can ask you the equation, you just write the product, it is wrong. So if the question is write the product, you know you meant to write the salicylic acid, ortho-hydroxy acetophenone, and benzoic acid. Not just writing them, the structure, because we are dealing with organic compound. So you have to write the structures. So if you write the name without writing the structures, you are not getting anything. You can just, if the mark of each of the products is 2 marks, you're going to just get half, because the cocoa is the structures. So the structure should go with the name. And make sure you understand the difference between orthohydroxy acetophenone is that there is hydroxy group in ortho position. Because we have acetophenone already, that acetophenone, that phenone functional group is, that acetofunctional group is carbon number 1. So any other thing become ortho because that's the main compound. So that's why we have orthohydroxy acetophenone. So salicylic acid is what we know is hydroxybenzoic acid. Orthohydroxybenzoic acid is salicylic acid. Virtually, we are virtually having the same. If you know benzoic acid, the orthohydroxyl is salicylic acid. If you know acetophenone, the orthohydroxy is orthohydroxy acetophenone. So with knowledge of 2 products, you're going to form 4. The only difference is that they have hydroxy in ortho position. So these are the 4 products formed when flavone, which is 2-methyl benzopyrene. So in case in the exam you did not see flavone, you saw 2-methyl 2-phenyl benzopyrene, it's still the same thing. So that you will not say, what I know is flavone, not 2-methyl. So it's still the same thing. Look at, if you look at this, you know that 2-methyl benzopyrene, 2-phenyl benzopyrene is flavone. So if you're asked 2-phenyl and we don't use flavone, don't get confused. It's still the same thing. Okay. Now, remember in 213, we talk about a reaction where aldehyde or ketone functional group undergo to form a product. Now, in this, we are also going to look at similar condition. Now, the flavone formed oxime with hydroxylamine, but they did not give phenyl hydrazone under ordinary condition. These are the reactions of aldehyde and ketone when they react with hydroxylamine, okay, to form oxime. So when they react with phenyl hydroxine to form phenyl hydroxine and others. So we're still going to look at that using hormone and flavone. So in this reaction, we are talking about these compounds, flavone and hormone, reacting as a carbonyl compound. Now, a question can be, how can you differentiate in its reaction difference between flavone and hormone using reaction? Now, if you look at hydroxylamine, both flavone and hormone are going to form oxime. Okay. Now, if you look at using phenylhydrazine, it is only hormone that form hydrazone. Why why flavone cannot react because of that phenyl cannot react. But when you talk about, okay, now phenylhydrazine, you can see my hormone is going to form hydrazone. Why my flavone is not forming hydrazone? What is this forming? It's forming oxazone instead of forming hydrazone. Because from knowledge of carbonyl compound, our phenylhydrazine form hydrazone. But in this case, we're not forming hydrazone with phenyl, with flavone. We're only forming hydrazone with hormone. Secondly, when we're talking about hormone can react with Brady reagents to form phenylhydrazone, but it cannot react with phenyl, with hormone, with flavone. So the two phenyl derivatives cannot form hydrazone under very mild condition. Why? So whenever we talk about phenyl hormone, it cannot react to form hydrazone. It can only react to form beta-diketone. So in the exam, you can differentiate between hormone and flavone using the reactions of carbonyl compound, which is condensation reaction. The name of this reaction is condensation reaction, because in the exam, they might ask you, what is the name of the reaction? Because it's what we did in 213, most of us might have forgotten that it's condensation reaction. Now look at another reaction of Wiener reagents. Wiener reagent, remember, in your reaction in 213, we talk about reaction of Wiener reagents. Wiener reagents can actually react with when there is presence of carbonyl compound, depending on what the nature of the carbonyl. We talk about that if you're talking about aldehyde, that all the aldehyde will form secondary alcohol except methanol, while ketone will form tertiary alcohol. So that's what you know in your 213. But now, talking about reaction with Wiener reagents of 2-phenyl and 2-methyl benzopyrene, we can form, what are we forming? We are not forming alcohol here. The essence is that in that, after the Wiener reagent reacting, which we know that when the bond cleaves, we are going to have two sections, the positive and negative, because my grenade has two sections. So the alkyl is going to go and attach to the negative, while magnesium is going to go and attach to the positive. Magnesium, alkyl is already positive, while magnesium is electropositive. Now, because magnesium is electropositive, it's going to go and bond with oxygen, which is electronegative. But because when we have two compounds that are positive, the one that has higher positivity is going to take electron share. They're going to take the positive share. Because alkyl naturally is positive, because magnesium is 2 + 2 in positivity. So that's why magnesium is going to take the positive, while alkyl become negative. So when this bond cleaves, you're going to have negative and positive. So where the carbon is going to be negative. So that carbon being negative is going to attract, that carbon being positive is going to attract the negative alkyl. While the oxygen being negative is going to attract the magnesium, positive magnesium. Now, in the presence of HS, HS can be HCl, HBr mainly. So that will be going to be a cleavage. What cleavage happens is that the cleavage is that the OMGS is going to cleave out in the place of an acid. So we have alkylated products. So from ketone functional group, we are going to end up with an alkylated product, forming benzopyrrolinium salts. So if a question is talking about reaction of Grignard reagents, Grignard reagents is going to form that is both 2-phenyl and 2-methyl benzopyrrole to form benzopyrrolinium salts. So in summary and conclusion, in summary of this flavonoid, in the class of flavonoid, we talked about what are flavonoids, what are antioxidants, and we related flavonoid to anthocyanin. And we also talk about how we can identify flavonoid in the lab, how we can quantify flavonoids. We talk about specific flavonoids. And we talk about the hydroxylation pattern in anthocyanin. We also talk about the reactions, the acid and base hydrolysis of a named anthocyanin. And we also talk about the difference between anthocyanin and anthocyanidin. Then we also talk about the reaction of ring opening when two derivatives of benzoylpyrrone react under alkaline condition. We also talk about the condensation reaction, just like the carbonyl compound of this derivative of benzoylpyrrone. Okay, we also talk about that this benzoylpyrrone can react to form a salt using Grignard reagents. So in summary of this class, we talk about, if you're talking about flavonoid, we're talking about flavonoid as a scavenging compound having 3 rings, A, B, and C ring. Okay, and we talk about that all flavonoid radicals decay by second order kinetics, although which you might not need as long as the exam of this compound is consigned. So just what we're going to know about is what are the flavonoids, what are the classes of flavonoid, what are different types of anthocyanin we have. We have a hydroxylation pattern. That hydroxylation pattern, you should know them. You should know their example in terms of flour. Okay, you should also know the structure and their distinct names and their IOPAC names. Now you should also understand the reactions of this flavonoid in terms of acid and alkaline hydrolysis. Please go and learn it very well. Understand the reaction of ring opening of 4-benzopyrrone. Understand difference between reactions, condensation reaction of flavone and chromone. And also how you can synthesize the anthocyanidin in the lab. Any questions so far on this before we talk about our class? Unmute and ask questions. Rosaline, do you want to ask question? So there's no question. Can we take our classwork?
I'm sorry, man. There's no need
At
for
least
us
some
to.
of you have predicted my classwork today.
I'm sorry, man.
So in the next class, we're going to talk about carotenoid. I would have shared the class the slide of carotenoid immediately so that we can talk about it. But I need to run to school because I'm not in school. So I can because of the next class. So let's take our classwork. Okay, number one question. At least you know the question. Outline the alkaline and acid hydrolysis of a named anthocyanin with a detailed equation. With a detailed equation only, outline the alkaline and acid hydrolysis of a named anthocyanin. Daniel, taking.
Yes, ma'am.
Daniel, or mute.
Yes,
So we
ma'am.
can be on the same page. Have you taken the first question?
With a detailed equation, outline the alkaline and acid hydrolysis of a named anthocyanin.
Like my volume is even low. Let
Taking,
me
ma'am.
check my setting. Oh. I hope you've been hearing me all this while,
Yes, ma'am. Yes, ma'am.
because I realized my volume was very low. Was I audible enough?
Yes, ma'am.
Okay, fine. So, question number 2. Can I go ahead?
Yes, ma'am.
The synthesis of anthocyanin. Show the synthesis of anthocyanidin. A detailed reaction step for synthesis of anthocyanidin. A detailed equation labeled equation on synthesis of anthocyanidin.
They say putting him in charge guarantees bias, not objectivity.
There are two derivatives of benzoylpyrrole. Mention them. There are two derivatives of benzoylpyrrole. Mention them. Which among them occur more in nature? There are two derivatives of benzoylpyrrole. Mention them. Benzoylpyrrole. Mention them. Which of them occur mostly in nature?
Sean Diddy Combs' lawyer had a
Benzoylpyrrole. Remember, in exam I can use flavone.
Can't imagine thousands.
2-phenyl benzoylpyrrole undergo
Can't imagine
ring opening using conc potassium hydroxide
the number of thousands.
with heat to form 4 products. Show a detailed equation for this reaction. Show a detailed equation for this reaction. 2-phenyl benzoylpyrrole undergo ring opening using conc potassium hydroxide under heat to form products. Show a detailed equation for this reaction. Show a detailed equation for this reaction. Just be giving the second. The first one is 1A. The two ones we talk about. The synthesis is 1B. The other two I talk about mentioning the derivative of benzoylpyrrole. How many I mentioned them? That one is C. The two of them are C. Then this one is number 2. Question number 2 now is where we are now. Yeah, number 2 now. Are we taking that?
Yes, ma'am.
So question number 2B. First one is number 2A. Number 2B. How can you distinguish between the derivative of benzoylpyrrole using condensation reaction? Using condensation reaction, how can you distinguish between the derivative of benzoylpyrrole using condensation reaction? Then last on this is 2-methyl benzophorpyrone reacts with greener reagent to form benzopyrrolium salts. Use equation to depict this. Depict this statement using equation or show the equation for the reaction. Show the equation for the reaction of 2-methyl benzophorpyrone with greener reagent to form benzopyrrolium salts. I think with this, we've covered everything we need to cover in this course. So if you have any question from the classwork, then unmute and ask your question. Now, the essence of this classwork again is number 1, 2. The classwork is for dual function. Number 1 is going to be part of your CA. CA before test. Number 2, if you're able to work on this classwork, follow it and understand it very well, exam will be like classwork for you. Okay, so because virtually we cover everything we say in the class via the classwork. So classwork is going to be an avenue for you to revise what you are taught. So when you come in the exam, you'll be familiar with it. It will not be a strange thing for you in the exam. So that's why I want you to take that classwork serious. Don't just copy from somebody and submit. Understand what you're writing. Let that be an interaction between your brain, your pen, and the paper. So that if there's any impromptu test, you will not be stranded. You will not say, I've not read. Please read along. Let's read along. It's very, very important. Okay, ask your questions. Any question? No question. So I'll see you in the next class on Wednesday. We're going to be talking about carotenoid. Then after that carotenoid, I don't know, somebody should move and talk to me. I want us to have a physical class. I want the next class to be physical. Can we have the next class as physical class?
I'm trying to check when our next class is, man.
Sorry?
I said I'm trying to check when our next class will be.
Next class is Wednesday.
Okay, Wednesday. That is 2 to 3.
Yeah. Because I don't know what I would do. I have to check the slides. If it's something we can finish in a class, then we'll have physical. But I want to make sure that it's convenient for everyone. Because I cannot have physical and I cannot have hybrid, physical and online. It's not possible. I don't have the whatever to achieve that. So let me know. If you feel that you guys are still struggling with accommodation, either we shift this class, the upcoming class, or something with accommodation. I will tell a prof to come and so that when you have accommodation, you have one physical class, which is carotenoid. I think that should be the best, right? Daniel, don't put yourself. Let's talk.
Let's have the next one online, man. Then
I'm going to punish
subsequently we can be having it as physical, man.
So do we do it that way? Prof, come and start alkaloid. Then when you guys are settled, I'll come up and finish. I want to have a physical class. One. If I do online all through, it's not very good. I don't think I'm doing well. In that physical class, you're going to have interaction. You're going to have one-on-one classwork where you're going to write with your paper, because at times some of you will just copy and paste. So I'll discuss with Dean and I will revert back to you guys. But as long as some people are already having physical class. When are you in school? Okay, discuss with yourself. When you say, I think I would discuss it. If Pastor I should go ahead and do physical, we do physical on Wednesday. And if she said we should continue online, then she will come online. That's that. So for your assignment, normally classwork is meant to be not to last more than 15 minutes. So for this classwork, As soon as I'm talking about it, I believe that you're supposed to be writing. So can you take the last attendance now?
Okay, ma'am.
Take the second attendance now. You guys are 52. Take it now and share with me. The submission, do you have class now, Daniel?
Yes, ma'am. Yes, ma'am.
Do you have class?
Yes, ma'am. We have class now.
By 11.
Yes, ma'am. 11 to 12.
Okay. So after 11 to 12, what class again do you have?
They will be having 3 to 4 CHM 431.
That 3 to 4, right? So
Yes,
now,
ma'am.
so by between 11 and 12, between 12 and 1. So I'm going to put deadline for submission to be 1 p.m. I can't let it to be in the evening because normally the classwork is meant to be submitted in a class. It's because of this online. Without giving you time to do it and submit it in class. So by 1 p.m. should be deadline. Please share it with me now. Don't share it as a word. Just share it as something I can just copy and put on the Google Classroom. Thank you.
Okay, ma'am.
So guys.